Okay, here we go. This is going to be number or exercise 6.3. I believe this came off of homework number 2 when we were working with the projective plane. This is going to be part A. I'm going to skip parts B and C for the interest of time. So what we want to do on this one is we just want to show that every projective plane, right, the projective plane has at least 7 points. So what we're going to do is we are just going to use the axioms to kind of build up to the 7 points to show there's a minimum of 7. And I'm going to show that there has to be a minimum of 7 using a proof by contradiction in the second part of this. Okay, so just right off the bat, in the projective plane, just by P3. So by P3, the projective axiom 3, it said every single line had to have 3 points. Right? So if I just go ahead, let's just draw a line down here. All right, so this line down here, it has to have points A, B, and C. So there are the 3 distinct points. So right off the bat, we already know that our projective plane has a minimum of 3 points. So what we're going to do is we're just going to slowly build up. We're going to go with 4 and then 5 and so on and so forth. Okay. So every projective plane has at least 7 points. Now, by P3, there exists 3 points. All right, we're going to call those A, B, and C. Okay. Now, P4, on the other hand, by P4, there exists a 4th point. Well, P4 specifically says there exist 3 nonlinear points. There exist 3 nonlinear points. I'm sorry, non-collinear. There exists 3 non-collinear. 3 non-collinear points. Okay, so even if we just had points A and B, what we could do is we could draw a point D up here. It doesn't matter what side we draw it on. I'll draw it down here. So we'll say point D. All right, so A, B, and D, maybe those are the 4 points or the 3 points, but we know every line has to have 3. So we have A, B, and C, and then we have that non-collinear point that forces a 4th point. All right, thus there exists at least 4 points. Okay. Now, what we can do is we have points A, B, and C, and D. We can sort of reference, or I guess use, let's see here. Actually, no, I take it back. We are going to use I1. We're going to reference I1, the incidence geometry. By I1, I1 gives us that there is a unique line. So any 2 points kind of define a unique line. It gives us that there exists a unique line. All right, so let's see here. We know there exists a unique line that contains 2 points. Okay, so what we can do is we can draw 4 lines. I'm sorry, 4 more lines. So for example, we have L1. We'll call it L1. L1 is going to equal the set AD. L2 we'll call BD. And L3. That's going to be, we'll call it CD. Okay, so what we're going to do is I'm going to go ahead and draw these 4 lines like so, and I'm going to show why I'm doing it like this in a moment. Right, so I1 gives us that 2 points define a unique line. P3 said there exist 3 points on any line. So now if you look at line AD, that's only 2 points. That's not enough. So what I'm going to do is I'm going to construct a 3rd point on each one of these lines. P1, call that P2, and we're going to call that P3. Okay, so when in reality, what we really have is each line containing 3 points. So I guess I really need to rename these. We're going to call this L1 equals, I'm going to call this DAP1, L2. We're going to call this one DBP2. Oops. DBP2. All right. And the last one, L3. We're going to call that, we're going to say that's the set containing DCP3. Okay. So now, just by here, just where we are right now in our proof shows 7 points. We have P1, P2, P3, A, B, C, and D, right? If we go off the picture, right, that's 7 points, but we know pictures are deceiving. So what we have to do is we have to show that these are in fact unique points. And to do that, we kind of have to do a proof by contradiction. So what we have to do is now let's just go ahead and assume we can say this without loss of generality. So assume without loss of generality that P1 is going to be equal to P2. Okay, so if we look at those top 2 points, P1 and P2, we're saying that's really the same point. So we kind of have an overlap. Maybe these lines curve around. Okay, however, if that happens, then what we end up having is, let's look at lines 1 with the intersection of lines 2. Right. Line 1 and line 2 both have segment D. All right, we're going to say segment D, and they both have that P1, P2. So let's just go ahead and call that point P. So let's say D1, or let's say P1 equals P2. So let's just go ahead and call that point P. Okay, so what we have is the intersection of line 1 and line 2 containing 2 points. But if we think back to I1 here, so I1 tells us that any 2 points define a unique line. So kind of what's going on here is we have something like this. This is going to be line 1, and this is going to be line 2. Okay, so they're kind of curving around. So that right there is kind of a red flag, but that's not enough information to bring out a contradiction, because if we have D and P on the same line, what really happens is that L1 and L2, L1 intersect L2, that implies, okay, that implies that points D, A, and B are collinear. Okay, so if we scroll back up to our picture, D, A, and B, that implies that D, A, and B are collinear. However, by assumption, all right, our second line here, we said P4, there exists 3 non-collinear points, and that non-collinear point was point D. Okay, so this right here, use purple, this right here brings up our contradiction. All right, so since L1 and L2 imply DAB are collinear, I should really write that down, implies DAB are collinear. Okay, that is our contradiction, because by assumption, we said D was our non-collinear point to line AB. Right? So therefore, we must have, thus we must have P1 cannot be equal to, there's no way P1 can be equal to P2. Okay, so we said without loss of generality. And what I mean by that is this would have worked for, P1 equals P2, or P2 equals P3, or P1 equals P3. It's the same argument to show those over and over. So essentially what we have is this plane has minimum 7 points. All right, we can't have 6. We could have an 8 point, but we don't really care. We just want to show that there exists at least 7 points. Okay, and these are the 7 points.